Bismillahirrahmanirrahim. Assalamu alaikum. My name is Professor Dr. Rizwan Jamil Qureshi. Welcome to the lecture number 6 of Software Engineering 2 course or Advanced Software Engineering. And I'm starting chapter 8 by Somerville, Software Testing. So what is software testing? What comes to your mind? Testing is a process to execute the program with the intention of finding errors. And as per IEEE, it's a process of operating a system or component under specified conditions to observe or record the results. That's by IEEE. Characteristics of effective software testing. So what are the characteristics of effective software testing? First, test the unit and then system. So we have unit testing, integration testing, system testing, acceptance testing. So there is a sequence. First, we need to perform unit testing. So what's the unit testing? Test each function, each module, each class, each component at unit level, individual level. For example, masalan, in my class, there are 5 students. Hussam, I assigned him withdraw module like ATM system we need to develop. To Mr. Faisal, deposit cash. Mr. Khalid, check balance. Mr. Abdullah, transfer cash, and so on. So Mr. Hussam will develop his module at unit level and test it. Mr. Faisal will test his module, deposit cash, and same the other students will do. After you have done unit testing, then you need to perform integration testing. So what's integration testing? Integration testing is performed to check the hyperlinks, interconnectivity, interoperability between or among the modules, between or among the classes or objects. Masalan, Hotmail system, Yahoo, Gmail. From inbox, you can go to the junk, new message, compose, and so on. So hyperlinks are working. And then data import and export. Output of one module becomes the input of the second or not. Here we have a concept of coupling and cohesion. So what's a coupling? Anything? Yes. Coupling means dependency and cohesion means independency. Two or more modules are dependent on each other that they cannot perform their functionality without the help of each other. Like couple, husband and wife. Wife is dependent on husband for earning, for financial matters. Husband is dependent on wife for the household matters. Like car. Front tires are punctured. Back tires are okay. Can you drive a car? Or vice versa. So husband and wife are like tires of the cars. They should be cooperative and they should work together. Then a family runs. Same, two modules are dependent on each other to perform their functionality. And cohesion is opposite of coupling, that a module can perform its functionality without the help of other module. But we always have coupling and cohesion ratios, like 90% cohesion, 10% coupling, 80% cohesion, 20% coupling, 70% cohesion, 30% coupling. We cannot have 100% cohesive module. Why not? Because it's not a solo system or solo component or solo module. It has to work with the other modules. It's a commercial system. We need integrated systems like ERP systems, like MADA, the ATM systems in Pakistan, One Link system, or Jawazat, Abshar, or NADRA in Pakistan, National Database and Registration Authority, ID card, passport, custom, tax. So we cannot have 100% cohesive module. It's not NASA module or NASA project. It's a commercial project and customer wants integrated systems. Another thing, we always ask the programmer to write a code with high cohesion and low coupling. What's the reason of that? What comes to your mind? Because easy to customize. So less customization is required, and we can reuse that code in another application, or we can easily update that system. If it is more coupled, then you need a lot of customization. And there is a rule of customization. If you need more than 60% customization, it's better to write the code from scratch, line 1. No need to reuse, because wastage of time, cost, effort, and resources. So we are talking about integration testing, like Hotmail, Yahoo, Gmail. You have compose or new message module, and you have send message module. As many mails you send from the new or compose message, you can see in the send message folder. So output of one module becomes the input of the second. If integration is not properly done between new or compose message and send message, the mails you will send, you cannot see in the send message folder. In contrary to that, opposite of that, inbox. If you are log on, automatically new messages will pop up and you can see them without the help of any other module. So it is less coupled, but it is more cohesive, whereas send message folder is highly coupled. So there is always ratio between them. Then you perform system testing. After integration, integrating ATM system modules, withdraw module, deposit cash, check balance, transfer cash, pay bill, you integrate them. You already perform integration testing. Now you perform system testing. That after integration, the individual modules which are performing their functionality, still they are performing their functionality after becoming a system as one system. Still can perform individual functionalities, or during the integration any bug is introduced or some code is missing. That is called system testing. Secondly, second characteristic, suitable testing method. There are so many testing techniques. We cannot apply all of them. So what is most suitable for your module or for your code, you select that. Then FTR sessions and walkthrough sessions should be performed. The third characteristic, FTR and walkthrough sessions should be repeated throughout the software development to assure the quality. And by quality assurance department, we have development department, quality assurance department. So testers are sometimes called them testers, and most of the companies call them quality assurance department. Not only in the software companies, it's also applicable for other industries like manufacturing industry, construction industry, education industry. Now it's industry, it's no more education, it's for business, especially in Pakistan. Anyhow, FTR, F for fish, T for tiger, R for rat. Am I correct? No. Formal technical review. It's a planned meeting and you inform the agenda to the participants before the meeting. Like you want to review some code. So you will provide them the code to the participants and ask them to have comments before the meeting to cover any error in the code, any missing function, any missing logic, or it's not developed as per the standards of the company, to assure the or confirm the standards of the company, unified manner it's written. So during the meeting, the mentor, there will be a mentor of the meeting like project manager or system analyst or team lead, will start the meeting and ask the participants to raise the comments. And then there is a scribe like JAD session, which will take minutes of meeting, which will record minutes of the meeting. And then there is a possibility to approve the code, enhance the code, or reject the code. In any case, before the next meeting, the mentor will discuss what are the comments in the previous meeting and they are addressed or not before starting the next meeting, before starting the new code, before discussing about the new code. And walkthrough session is unplanned meeting. The project manager, system analyst, team lead, or scrum master in Agile will pass by the programmer and ask him to explain that this code is written according to customer requirements or not, or explain the logic of the code and try to identify some bugs in the code, or try to guide him that this is not efficient algorithm, you can use this algorithm, and so on. So these are the characteristics of effective software testing. Then there are fundamental principles of software testing like testability. The software should be written that it can be easily tested. Ease to test, that is the testability. Operability, easy to test the functionality of the software while executing. Observability, the real inputs and the expected outputs should be visible to the programmer, that the program or software is executing the results as per the test cases, as per the test data, the real data of the customer. Incorrect output will be easily recognized to trace the error in the code. That is the observability. Controllability. Small size software is easy to control as compared to large size software. Small section of the code, classes of the code, modules of the code, because like the case of Vista or Symbian operating system or Netscape communicator browser, the size of these softwares applications were so large, or the operating system was so large in the Vista, that Microsoft, which have the best programmers in the world, still they are not able to fix all bugs in the code, and it was a failed product by Microsoft because size was so large, difficult to test, difficult to debug, difficult to maintain. Decomposability. Always try to divide the large functions into smaller functions. So once you minimize the scope of the code, easy to test in terms of faster testing. Simplicity. Simple architecture, simple design, simple code will always be easily tested. Stability, like in reliability, we say the software should have minimum bugs and it must be stable. It should not crash. If the software is stable, easy to test. Otherwise, if it is crashing again and again, you need to re-enter the inputs, check the outputs again and again. Wastage of time, wastage of effort, wastage of resources, budget. Understandability is another testing principle. If you understand the code as a tester, you understand the architecture, it's always helpful for the software quality assurance engineer or the tester to test the code. That is the reason some software companies, they have a requirement that if you want to be hired as a tester, as a quality assurance engineer, you must have 2 to 3 years development experience. So in specific language, what language the software company is using, like Java or .NET, C#, .NET, ASP.NET or PHP or Python or Ruby. So good understanding of the tester should be there. He is easily understand the code and he knows the inside architecture of the code, internal architecture of the code. Characteristics of test case. Test case should be unique, should not be repetitive. Like you test 1, 2, 3, there is no need to test 3, 4, 5 or 6, 7, 8. Or you test ABC, no need to test again with D, E, F or G, H, I, J, K, something. It must be best of its type. It can identify maximum number of errors in the code. Test case should not be too easy. It should not be too complex. So there are 3 characteristics of test case that you must know before you go for testing. What are the main types of testing? Anything? We have 2 types. We have validation techniques and we have verification techniques. What is verification? Verification means you test the software that it is functioning correctly or not. It is giving you correct results or not, correct output or not. Like for example, 2 plus 3 is equal to 5. 2 plus 3 should not be 6. If it is 6 mean there is a logical error. So instead of plus sign, you put multiply sign. So that's the verification. Validation. Validation means software is functioning as per customer requirements. What are the customer specs? It should function as per the specs. So this is called validation. So first we verify. When we write a code, we verify and then we validate. And verification starts not only for code, from planning document, project specs, analysis document, the functional specs or system requirement specification, design specs, then code. Whereas validation started after writing the code. You can only test the software in terms of unit testing, integration testing, system testing, acceptance testing after writing the code. So that's the difference between verification and validation. Sometimes we say validation and verification. How many approaches are there for testing under the verification and validation? Anything? We have white box and we have black box. What is white box? White box is also called glass box, clear box, or structural testing. Like my cup of tea, it's made of glass. You can easily see inside. Whereas my mobile, my mouse, my printer, my computer, they are black box. I cannot see inside. Like aeroplanes, after crash, the investigators look for black box to listen the last conversation of pilot or co-pilot, that what happened to the plane before crash. So every plane has a black box. Same, we have black box testing or functional testing. It is also called functional testing or behavioral testing. So white box, glass box or clear box or structural, whereas black box is called functional testing, behavioral testing. So in the white box, you have source code. You can see the source code and you can read that code to identify the errors before you go for execution. So white box is performed before the black box. So your effort, your resources will not be wasted. You try to minimize the wastage of the resources by performing the white box testing. Whereas black box, you don't have source code. You try to identify the errors while executing the software, through the functioning of the software. That is the reason it's called functional testing or behavioral testing, how software behaves. Sometimes we don't have source code because it's developed by third party or it's COTS, commercial off-the-shelf components for the systems. So white box is used to identify the errors in the structure of the code. The main sources of white box testing in terms of identification of errors or introducing errors. So a number of errors in the code introduced because of incorrect translation of requirements and design, misunderstanding, confusing requirements, ambiguous requirements, unclear requirements are the sources of introducing errors. Because you understood function specs wrong, design specs wrong, and code will be wrong. So poor analysis, poor design, poor implementation. Some errors are introduced by the programmer, like syntax error or logical error. Syntax errors are easy to report because program will not execute while performing the black box, whereas logical errors are difficult to identify. You need to read the code to identify them. White box testing helps to reduce the delay between the injections of the code. So it's a previously we can say preventive measure. You try to minimize the errors, you try to identify the errors early in the development stage, while at the end you don't have time to fix the errors because of the pressure, because of the gun point by the customer. Hurry up, Sura, jaldi, and you don't have time and you do a lot of mistakes while under the pressure. The push strategy is there, always adopted by the customer, So every software, we test the software in terms of white box by examining the code, by reading the code. Whereas in the black box, we execute the software, and by functioning of the software, we try to identify the errors in terms of expected outputs. Main types of white box testing. We have static testing and we have structural testing. Static testing is a type of testing which requires only source code, not the object. So we test the software to make sure it works according to functional requirements, it's written in accordance to design, any functionality is missing handles error properly. Main advantage: humans are better than computers to find the errors in some ways. You can catch multiple errors in one shot, or you have diverse views, multiple people are there, they can, or peer programming in agile, two programmers work on one machine, you write the code and your colleague will test it. So you are not the best person to test your code, because your code is your child, your product, and you don't want anybody will abuse your child. So you will not find any mistake in your child, but third person will have neutral opinion. Humans can detect multiple problems, many problems, and can identify the root cause of the problems. Whereas computerized testing can identify one error at a time in terms of test data, test classes, and you need a lot of time. If you did not perform the white box testing and you directly go to the black box testing, a lot of time, cost, effort, and resources will be consumed. Human test the code before execution, computer resources are saved. Then, as early you identify error, as easy to fix that. As delay, it's difficult to identify, difficult to fix because of the time constraints by the customer. Main types of static testing: desk checking, code walkthrough, and formal inspection. So what is desk checking? Desk checking is always done by the programmer at his desk. So it's most cost effective, but if you are not applying or using pair programming technique, then it's not worthwhile, it's not beneficial, because many errors will be remained in the code because you are not the best person to test your code. Code walkthrough and formal inspection I just covered when I talk about formal technical review and formal inspection, so I'm not going to repeat here. Main advantages of desk checking: programmer is the best person in terms of understanding his code, and he understands the language. No overhead cost. Disadvantage: you are not the best person to detect your code, so that many errors, many bugs will be remained in the code, and programmer or developer always prefers to write new code as a challenge, not repeating himself again and again, fixing the same code. Person dependent and does not work always. Main limitations of formal inspection: time consuming, cost consuming, and it's not possible to go through every line of code. Then, structural testing, another type of white box. Structural testing means you try to read the code in terms of structures, like control structure, possible outputs, if else structure, select case, switch case structure, and you have main types. I will cover them inshallah in the next lecture. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.